Mobile Mind is aiming to return autonomy to wheelchair users whose needs aren't met by currently accessible technology. Joystick-controlled wheelchairs aren't viable for many users who have limited or no use of their hands. Mobile Mind is a fully hands-free electric wheelchair steered with eye tracking and driven with your thoughts. We are the team behind Mobile Mind, and we're excited to explain this project to you today.
Mobile Mind tracks the user's irises using an external camera and a computer vision model to determine where the user is looking.
Once we know where the user is looking, we can then turn the wheelchair to the right or left.
This allows for completely hands-free steering.
Mobile Mind also collects brainwave data through the Muse meditation headband in order to control the speed of the wheelchair. Compared to the traditional EEG headset, which is hard to wear, uncomfortable, and completely impractical in everyday application, the Muse is a non-invasive, wireless, and easy-to-use solution to this problem. The EEG data that we've collected using the Muse headband in our training program is then used to detect the speed that the user wants to go at. Our machine learning model can predict the user's intent with 85% accuracy.
The hardware system provides a cost-effective method of powering the wheelchair. The drive system integrates e-bike parts with pulse width modulation control and a resistive braking system. This allows for the wheelchair to retain both manual and push use while also enabling Mobile Mind capabilities.
All these systems come together on the onboard Raspberry Pi, where the signals from each of the subsystems are processed into directional data. The Raspberry Pi keeps an internal state of the speed and angle that the wheelchair should be going. It updates that state based on the EEG and eye tracking data. These state values are then converted from an angle and speed to PWM signals to be sent to each motor. Up next is a narrated demo of the state of the project as of March 26th. In the footage you're watching, the user imagines himself moving forward. This signal is processed by the prediction model, causing the chair to accelerate. The user then looks right, which is picked up by the eye tracking camera, causing the chair to veer right and into the center of the hallway as the user looks to the left and straight again to center the chair. The user then comes to a stop after imagining himself braking. The user focuses on accelerating again, and again the prediction model sends a signal to the chair to accelerate. Here, the user looks to the right and is able to avoid his collision course with the water fountain. The user then imagines himself braking and is able to stop himself before reaching the wall. In this clip, the user imagines themselves accelerating, causing the wheelchair to accelerate. The user looks to the left in order to make a left turn to continue down the hallway. The user then imagines themselves braking in order to come to a clean stop. All in all, at Mobile Mind, we believe we've created the most intuitive wheelchair experience for anybody. By leading the wheelchair through simply thinking and looking, you can get where you want to be without moving a finger.